Thank you, ma'am. All right, so like we were saying, you'll see this V here. That implies that we're probably dealing with one of these absolute value graphs. You're going to see up here, you see this absolute value equation. We were kind of doing absolute value equation. We've been quizzing. We've been looking at piecewise functions. We talked a little bit yesterday how those are related, and today that's kind of what we're really going to jump into fully. So it says below, number 8, the graph below is another example of an absolute value function. And again, it's because it's this nice V. And those absolute value functions are what we introduced yesterday. The equation of this function can be written two ways. So one way we can do this is using absolute values. So that's one way that I could write this equation. That equation looks like this on an xy plane. Yeah. So. Yes. All right. So that's how we can write this with the absolute value function, or we can write this as a piecewise function. Either way, that's what this graph would look like. So these are one and the same. They're just different ways of writing this graph, an equation for this graph. So we kind of want to understand, if I give you this, so long term on this set of notes for the homework, you'll get some homework tonight. If I give you this, how could I turn it into this, or vice versa? If I give you the absolute value graph, how could we turn it into this guy? All right. So that's kind of what we want to get to here. So in terms of this, what we kind of want to observe here, it says, how do these two equations relate to each other? So if we look at this, first thing I want you to write down, when we look at these two, so again, we're just comparing what I have highlighted up here in the yellow. All right, if you look at kind of what's similar, what's kind of similar, what's somewhat different, both of those inside of the grouping symbol. So here's the absolute value, here it's your parentheses. They both have an x plus 3. Here it's inside absolute value brackets. Here it's inside of our parentheses. But both of them have that x getting increased by 3. All right, so that's one thing we kind of want to observe eventually when we kind of start working back and forth between them. The grouping should be the same. Whatever's inside of the absolute value brackets should ultimately be inside of the parentheses and vice versa. All right. All right, number 2, behind the grouping symbol. All right, so that's behind the absolute value bars, behind these parentheses, behind the groupings. Is a 0. We don't see the 0 because we don't need to write it in. But since there's nothing added to this here on the back end, that just would mean there's a 0 there. Same with these. There's nothing added or subtracted on the end. The reason for that just means there's a 0 there. But it's the same in both. So whatever is added or subtracted on the back end of one should be the same as it is on the other one. All right. The third one, and this is kind of this big one here in terms of what we're going to want to really focus on today. If I look at the coefficient of the absolute value of x plus 3, if we know what coefficient means, that is the number in front of a variable in front of the variable term. In this case, it's the number in front of these absolute value bars. So if we look at this absolute value bars, I don't have anything written in. So what that implies is that number is a 1, and that's why we don't have to write it in. All right, so there's really just a little 1 right here. There's just no sense in us writing it. Then, if we look at these two piecewise functions, these are the equations of these lines. So if I now ask you the slope of this line and the slope of that line, we could count it off if we want. We could also just look at the numbers in front of our parentheses. The slopes of the lines are a positive 1. That's this one over here. So this is the one that has a slope of a positive 1. And then if we look at the other one, this one, so we did that a number of times yesterday, is a negative 1. So this coefficient here is a positive 1. What that translates to be over here isn't just a positive 1. It tells us that the slope of those two lines are both a positive 1 and a negative 1. And that's why we're creating that V there. All right. So those are some things that we kind of want to recognize. Last thing, if I ask you what this vertex is right here, so we started reintroducing the idea of a vertex yesterday because we did that a lot with parabolas. If I ask you what this point is, all right, that lowest point on the graph, if we said this is x is a -3 and our y is a 0, notice what we have inside of these parentheses or the absolute value bars here. Very, very similar to our parabolas. If you think back to when we were doing parabolas, and we would do x minus that x coordinate, and then we would have squared it. The reason we get this to be a +3 is because the x coordinate is a -3. So really, really similar behaviors that these graphs are going to have that those parabolas had that we did for a long period of time. Okay. So those are some things we want to notice about this, so that when we start to do these, we can kind of start working back and forth between an absolute value graph and then that piecewise graph. Okay. All right, so now this one, it says below are some graphs and equations of linear absolute value functions. Write the piecewise function for each, and then see if we can start to kind of create a strategy that would make this nice and quick. All right, so in this case, that's your absolute value graph. I am giving you the equation. That's what it looks like in terms of an absolute value. What I want you to do is to come up with the piecewise function. We quizzed on Friday. We did some more of them yesterday. So real quick, let's see if we can do that, because this is what we pretty much did yesterday. Write the piecewise function. Here's one part of it. So that we'll put in the first line. And then we also have this line right here. So then put that in your second line. Okay, so we did another 6 or 7 of these yesterday. Do that real quick. Let's see if we got a handle on that. And again, the point we want to use, a few people weren't here yesterday. When we do that, always use the vertex point. Always use the point that's shared by both lines. Okay, so in that case, we want to use this point right here. Quick little reminder. Good. All right, good. All right, slope. Ben, what's the slope of our blue line here? Good. So the slope of that blue line, you're just going down 1, right 1, down 1, right 1. So we're going to throw a -1 in front of that. And then since I tell you to use this point, and we still want to do that, this should have been the point 1, comma 2. That's the point that's shared by both of them. So inside we'd have x minus what, Ben? Good. So x minus a 1. And then on the back end, you're going to have a what? Good. +2. All right. So that should be the first one. When I go to the second one, Jada, what was the slope of the yellow line? Good. That's just a +1. And then we talked yesterday, if I'm using the same exact point, shouldn't the second one look identical to the whole second part of the first one? So this should also be the x minus 1 plus a2. All right. Then we want to identify our interval. This point starts at 1, and we want everything to the left of 1. So those are all x values that are less than 1. The yellow line starts at 1, and we go to the right forever. So those are all x values that are greater than 1. And then put your equal sign anywhere. I've been putting it in the first one. As long as one of them is closed, it doesn't matter. But all the values left of 1, all values to the right of 1. All right, now think back to what we talked about. So let's compare these. This is our piecewise function. And then this was our absolute value function. And let's see if the same things that we talked about before are still true. Look at the number in front of that of the absolute value bars. Since there's nothing written there, that's implied that that number is a 1. Notice what the slopes of your two lines were. They're both 1s. One is negative, one is positive. If we look at this point that I used, the x minus a 1 plus a 2, x minus a 1 plus a 2, when I wrote the P or the absolute value function, don't we have the exact same thing, but instead of parentheses, it's your absolute value bars. Okay. So kind of keep that in mind. And that's, again, eventually when I just want you to go from one to the other, that's what we're going to want to do. All right. So number 11, let's use the graph one more time. Same idea. Write the piecewise function for this V-shaped over here. So it's two parts. We should have two different lines. When you do this again, I would like you to use the shared point, all right, which is the vertex. All right, this one, yellow one. The slope of the yellow one, Sarah, what would that be? Good. So the yellow one has a slope of a -1. Let me jump right to the slope of that second one. What do you get for the slope of the second one, Sarah? All right. So again, understand if we don't want to graph this, or if I don't give you the graph, let's say I just kind of deleted that whole graph out of there. Notice the number in front of our absolute value bars is a 1. And notice how the slopes of those are also 1s, but one's positive and one is negative. Okay. Then if I ask you if this is the point you're going to use, Sarah, what is this point? If I wrote this as good. So 0 and then that +2. So this would be x minus what, Sarah? And then on the back end, you're going to have what? Good. And then that would be identical for the second one. So you're going to have an x minus a 0 and then plus your 2. And then now we would never really write it with that x minus a 0. It's unnecessary. So couldn't I just erase that 0 because it's a 0? And then again, don't these look identical? I have just an x in the absolute value bars, just an x in the parentheses. They're both being increased by 2 after that. So with that, again, these are identical, except this is an absolute value bar instead of the parentheses. Okay. Then when we do our x's, this is 0. We want all x values to the left of 0. The blue one is all x values to the right of 0. Close off whichever one you want to close off. I'll close that second one. We just need to make sure one of them has the equal sign underneath it. All right. All right. So now this next one. See if we are understanding this. I do not give you the graph. So what I want you to do first is to look at this equation here and see if we're understanding. We did the one together, then you guys just did those last two. If that's your absolute value equation, what does the piecewise equation have to look like? All right. What were those similarities between them? Yeah, go ahead. Okay, if you're confident in that, because I am seeing some good stuff over here, see if you can graph it now, because that's going to be our next thing. So how would that look as a graph? Okay, saw some good stuff for the equation here. Lily, what'd you have for the first one there?
A negative 1 and x minus 4 plus 0.
Good. All right, what was your second one?
There was positive 1 minus 4 plus 0.
Good. Where'd the negative one, positive one come from? How'd you know that?
Because there's nothing in front, but then it's usually something.
Good. Right here, she said there's nothing written in front of those absolute value bars, so we knew that had to have been a 1. And then every single time that coefficient right here happens to be the positive and negative value of your slope. So that's got to be negative 1, positive 1. And then everything else is identical. Instead of using absolute value bars, you could just write that same exact thing with parentheses. And in that mode, you don't necessarily need those zeros there, okay, if we want to make it look like that. Now, for the sake of graphing, I am going to add those zeros, but you don't necessarily need them. And then it looks identical to number 12. Let's graph this first, because here, looking at some graphs on this side of the room, it was 50-50 in terms of if we graph this correctly or not. Once we have the graph, then we'll go ahead and say what x value are we less than and what x value are you greater than. So if this is point slope form, and I ask you to write the point that we would have used to come up with that, the really easy point is 0. Looking at everybody who did it over here, 0 is clearly the y coordinate. If this is x minus 4, what is the x coordinate? And this is where we were kind of 50-50. Is it a positive 4 or a negative 4 for that x coordinate? What do we think, Lily? Good. Should be a positive 4. So this, if we go back to all of these here, notice how this point, this is 0, 2 in this one. There's a 0 and a 2. That's your vertex. If I go back to this one, this should have been, if we look at our point here, positive 1, positive 2. That's because this is x minus 1, x plus 2. Whatever that point is, that's your vertex. We want to plot that point. So you're going to plot the point 4, 0. So just plot this one correctly. This is where I did see some people over here at negative 4, 0. So this should be our vertex. And then just understand how we would now graph these. Let's do this one first. I think this one is the easiest one to understand. We have the point plotted, 4, 0. Now just graph a slope with a line of 1, or a line with a slope of 1. So from this point, you're going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Understand what this is supposed to look like. This has to be a V shape, right? Any absolute value we've done so far is a V. So when we draw this, this should be your vertex right here. This should be the lowest point on our graph. So you do not want to continue this line in this direction. Okay, this is where it starts, and then we go up. Now, here's the tricky one. So see if you can kind of do this before we show you. See if we can put this together. Graph this part of it, because the other line better have a slope of a negative 1 to create that V. So from this point, count off the slope of negative 1 and create that V that we need. We know it's a V. Do that. See if we understand how that would play out. Because your initial instinct might be wrong, but hopefully we can think it through and figure out what you're supposed to do. All right. Once you think you have it, go back. Has every problem we did yesterday, the 2 that we have right here, aren't these all V's that open upwards? So if you don't have a V shape that opens upwards, there's an issue there. Now they can certainly open sideways and down. We'll get to all of that, but right now we're not doing any of those. These should open upwards. So look at your graph, see if it opens upwards. All right. And then if you did, probably right. Assad, how did you do yours? What did you do from this point? What did you do? All right, so he went from this point. How would I count that off? I'm going to go upwards by negative 1.
So you go up 1, right 1, up 1, left 1.
Good. Up one, left one. Good. Good. And if we keep doing that, that's going to give us our graph. What you want to be careful of doing now, and this is probably your first instinct. If I'm at this point, a slope of -1, your first thought could be to go down one, right one, down one, right one, down one, right one, because that's correct. That is a slope of -1. But if I drew it right here, is that going to create an upward opening V? No. So what Assad said is perfect. We instead want to always work our way up and then count off that -1 by going up one, left one, up one, left one, up one, left one. All right. Good, Assad. All right, so now we can go ahead and do our x values. We see that this is the vertex of 4, 0. So to the left is all the x values less than 4. The right-hand side of that graph is greater than 4, and then make sure one of those gets closed off. Okay? Okay, try that again. Do 13. Same idea. We should be able to look at that and write this piecewise function very quickly now, hopefully. And then once you have that, understand what your vertex is, and then plot that, graph it. Good. So people are already done with the 14th, so that's good. All right, let's see here. Alec, what'd you get for this first one, Alec? Good. So you're going to have that negative. I'm going to put it into parentheses. You don't necessarily need to use parentheses, but just so it looks like this, I'm going to go ahead and put in parentheses. And then he said plus a 1. So now this should look like that. What was your second one, Alec? Good. Just a positive 1. And again, you don't necessarily have to do that. Plus 1. And then it should look pretty much like that. So one's a positive 1, one's a negative 1. If I now ask you where this vertex is at, the fact that this is an x minus a 0 in here, there's nothing there. What was our vertex, Alec?
0, 1.
Good. 0, positive 1. So I'm going to go to that point, 0, positive 1. To the right, I'm counting off a slope of this positive 1. So we're going to go up 1, right 1, up 1, right 1. And to the left of this point, I want a slope of -1. So hopefully if you did this the first time, you got it corrected the second time. We don't want to go down 1, right 1, even though that's counting it correctly. To ensure that we get an upward opening V, you go up 1, left 1. That's how we create that slope that's a -1. And then we see this is the x value of 0 right there. So Ella, what'd you settle in on here? It's all x values, what? Good. And the right one? Good. And then x is greater than 0. Okay. All right. 14. The last one of these, something a little different, but it follows the same exact pattern. See if you understand what's a little bit different. And if you do, you should still be able to do this pretty similar to the first two there. let's see where we're at here. Julia, what do you have for that first one? Good. So in the second one, good. So in this case, for the first time, you don't just have a 1 right there, but now this should be even easier. We see that that's a 3, so that just means we have a -3, +3. If I then ask you for the point where our vertex is at, Monica, what point would that be? Good. Since this is x plus 2, that means our x is a -2, and then we have that +1 on the back end. So -2, +1 is right here. And then like we have been, you're going to count your slope off. Just now count the right slope. Let's do the +1 first. I think that's the easiest. The +3 means from this point, you now go up 3. 1, 2, 3, right 1. 1, 2, 3, right 1. And then the -3, again, don't go down 3, right 1. We instead want to go up 3, left 1, up 3, left 1. And then we would connect those. And then remember what we talked about with parabolas? Remember how the bigger this number got, the tighter it got, the more narrow it got? It's the same exact thing with your absolute values. Okay, that just got really narrow in there. Okay. And then the x value is a -2 right here. So the first one are all the x values that are less than a -2, and then the second one are all the x values greater than a -2. That's the piecewise function for this. Okay. All right, real quick while I give you the homework, do this for me. Let's say I instead add a 15 and do this piecewise function. And write the absolute value equation for this. Haven't had you do that yet. So what would that look like over here if you're going to do the absolute value part of it? So now you're going to make it look like one of these guys. Okay, so now make it look like one of those. What would that look like? All right. Joe L., what do you think? What do we have first?
2.
Good. So we're going to have that +2. We see that our slope is -2s, +2s. That means there's a 2 in front. And then what?
X plus 5.
Good. And make sure we're putting absolute value bars now. So those vertical lines are absolute value bars. And then you'd have what on the back end? Good. That's how it would look on the back end. Okay. All right. The homework. I want to do the first one together, and then you can do what you want with that if you wanted to start cranking that out. But go to the first one because where is that? It's worded a little differently. So I'm now just going to give you, actually try it while I find it. So what I'm giving you in that one, I just give you the graph. So based upon the graph in number 1, write either one of those, whichever one you could do, because now we should be able to work back and forth. So if you look at number 1, look at that graph, write the equations for me. Okay? And I got to find it. This guy. All right, good. Karina's doing the piecewise function first. Omar's doing the absolute value function first. So whichever one you think is easier, do that, and then we should now be able to convert them. Okay. I'm going to start with Omar, though. Omar, that absolute value graph, how could we jump right to that? What would that have to be? What's in front? Good. So there's a 1 in front, so we didn't write it. And then we would have those absolute value bars. And then what'd you have inside of this? Good. X minus A3. And then what do you have on the back end? Good. And then plus what? Good. Plus 2. So he understood this was his vertex, 3 comma 2. So that's why he did X minus 3 and then plus that 2. And then our slope here is a 1 to the right of it. It's a negative 1 to the left of it. So we knew out in front there had to be a 1. All right, and then you would do the piecewise function based off of that. You can either use the graph or you can now use this equation. All right, and then I lied. We're going to do number 3. Go to number 3. See what you think about that guy. And how would that change things? All right. Let's see if we're on the right track here. Assad, what'd you get for the absolute value equation?
-2 times that x and then plus 5.
Good. I'm going to put the 0 here. So he came up with that. If he got that, that is correct. He got the 0.05 from just looking at this vertex right here. That's no different than any of the other ones we've done today. So that's why there's an x minus a 0 plus a 5. We have not talked about this in regards to absolute values. Why did you make that a -2?
Because it was going down.
Okay, just like our parabolas back in the day. Remember how we had parabolas that opened upwards and parabolas that opened downwards? The number in front tells you if you're opening up or downwards. So far, everyone has been opening upwards because the number here has always been a +1 or a +2 or a +3. As soon as this opens downwards, whatever that numerical value is right here, you need to make it negative in front. All right, just like a parabola. All right, then be really careful with the piecewise function also. So if I now go to write this piecewise function, so Lily, what do you have for the first one here? Good. So she just said, I'm going to do x minus 0 again, but what you have is fine. And what do you have for the second one? Good. And then she had the same exact thing for this one. So now here's where you need to be really, really careful, because let's look at our slopes here. Here's this point. If I ask you the slope of the line on the left, which one is this? Is this the positive slope or the negative slope? So is this line going up or down? Up. So isn't that the positive 2 right here? So now I'll take it either way, but since Lily gave us this one, the one that has the positive slope is the one that has all the x values that are what? Greater than 0 or less than 0? So is it going left or is it going right? So if we do this one, it should be what? Shade it. And then here's the x value of 0 right here. So is the yellow part to the left of 0 or to the right of 0? Left. And if it's to the left, what inequality do we need if that's one to the left? The less than sign, so this guy, or the greater than sign if we're going to the left? What is it, Omar? Good. So this is where you're going to put the less than sign if you put the -2 first. Okay. Then the second one, all the values to the right of 0, this is when you're going to get your -2. So the -2 is the line that is greater than that 0. And then you're going to close one of them off. Okay. I would take that. You can also actually put this one first. If you do x is less than 0, greater than 0, like we have been, then you better have these flip-flopped. You better have the +2 first, the -2 second. Okay. So that's what happens if it opens downwards. All right. All right. The homework is all of these. We've just got 2 of the 7 done, but it's all kind of the same thing. Graph, piecewise function, absolute value function. We should be able to work with whichever one you're given and get the other 2 parts. All right. All right. Stop this.